Hi, this is the solution for the question 1 of homework 11 from Hw11, and here first we look at this problem, this question. It told us that xt is a real WSS process, and told us its autocorrelation and its power spectral density SXS omega, and it wants us to show that first its autocorrelation is real and even, and second its power spectral density is even and non-negative. And it is very easy and directly we can read its autocorrelation in this form. It's the expectation of xt plus tau times xt, the two expectation. As we all know, xt is a real function, so two real functions multiply together, the result is also real function, so its expectation is also real. So we get prove this first property, and for the second property is that it wants us to show that it is even, and it is easy that we can read this into this form because x is WSS process, so it's no matter we change the time in the xt, is the result it doesn't change, it doesn't matter. So we make this change and we change their position and get this form, and we notice that in this form it can equal to that the function that x, the correlation of minus tau. So from this equation we can know that the autocorrelation function is even and it's real and even. And for the sub question B, it wants us to show that power spectral density function S omega is even and non-negative. It is also easy and directly we can know that the power spectral density can be is a Fourier transform, and also we can write this into this integral form, and we can split this term e into two parts, the real part and the real part and another part. And we should notice that because the from here we know that x tau the r tau is even, so this one is even and this one is odd, so this one in totally is odd, and we from minus infinity to positive infinity we can get this one, the result is 0. So for this one, because it is this one is even and this one is also even, so the result is even. It is equal to the two times of this from 0 to positive infinity interval, and because the cosine function is even, so we can make this change, it doesn't change, so it from this definition we get the power spectral density is also even. And to prove it's non-negative, it is easy. We can give an example that we build a bandpass system here. Here's the system H omega equal to 1 when the omega greater than omega 1 and smaller than omega 2, and in else it equal to 0. So we can calculate take use of the property of the expectation of yt square, and it's easy to know that because this one equal to equal to 1. So it is equal to that the spectrum function from omega 1 to omega 2 is integral. And because omega 1 omega 2 is we can make any it is for any omega 1 and omega 2 is this conclusion can be correct. So in this way we can know that to make sure this assume correct for all the time, there must be the this function is non-negative.